then next on stage, we can invite Jakob Kasbauer from the Deggendorf Institute of Technology. He works there since 2019 in the Applied Artificial Intelligence for Context Recognition research group. And the project he's going to present to us is SOVIA. So it's basically an LLM-based social voice assistant for aging at home. And we will hear a little bit about the architecture, the field study itself, and I'm very, very excited about this topic because we hear also research a bit about the combination of technology and healthcare. The stage is absolutely yours. Thank you so much for being here. A big round of applause.
So, good evening, everyone. Today, I'm going to present you the research project SOVIA. SOVIA is basically an LLM-based social voice assistant to reduce loneliness for the elderly. This research is an ongoing project, so therefore I will only present the architecture, the design decisions, and the evaluation. The field trial is yet to come, so the empirical evaluation is still missing. So what's the motivation for this? Why is loneliness such a problem in the elderly? Well, this realization comes from previous research where we deployed commercially available voice assistants into the homes of the elderly. And after 4 weeks, we discovered some interesting usage patterns. A subset of users reported that they form friendships with the voice assistant, but we also see the risks in them. So the users do attribute the personality to those assistants, they do anthropomorphize them, and they treat them as a real human being. And a lot of some participants said that they're really glad to have someone to talk to. And loneliness for the elderly is a rising problem because usually loneliness increases as you age. This is especially true for people with reduced mobility, such as bedridden people, or people who live alone, for example, after the death of a spouse. So why don't we just deploy commercial voice assistants into the home of the elderly? Well, we observed some problems with the application for a companion. And this is why we created the research project SOVIA, where we try to address the limitations of existing voice assistants, and we will implement additional features that aid the role. So, the technical gap for so comparing a commercial voice assistant to our project, a commercial voice assistant is purely passive. It only reacts when spoken. It is not suitable for sustained dialogue. And we want to create a sustained dialogue over a whole month where the user can form, I wouldn't call it friendship, but some kind of kinship. So this way, we try to create a user memory module where the voice assistant learns from the user. We also try to address the problem of passivity. So therefore, we create a set of dialogue topics where we introduce proactively conversation topics to the user. This is useful because otherwise we have the risk that the participants just forget about the research and the assistant. For the technical side, we designed a system with data protection and privacy in mind, also with ethical constraints for deployment. And we optimized it for the needs of the elderly and the needs of our study population. So therefore, the system must speak German in a voice input and voice output manner. It must run locally hosted to avoid data protection and privacy problems. And we also address the usability problems for the elderly. This means problems in visual acuity or fine motor skill. That's why a voice assistant is so useful. To evaluate the system, we do a field trial with 10 participants where we studied the effectiveness in reducing loneliness. So, not working. Oh, too much. So let me briefly introduce the technical architecture. So in the core, we have a chat loop where the user interface is a tablet-based computer with a microphone and a loudspeaker. So the user starts a conversation with audio input. The audio input gets translated with speech recognition into text. Then a large language model does text ingestion and text generation. And finally, we synthesize text with a text-to-speech model and play the sound back to the user. This is a fairly standard architecture. There is hardly any innovation in it. But on the right-hand side, you can see the extensions that we designed for SOVIA. So first, we have the user memory module. The user memory module summarizes the whole chat history into a shorter fact-based summary. This addresses the problem of context rot. So large language models, the output quality degrades as the chat history gets longer. And in our use case, the chat history can be like multiple hours per day over a whole month. So it's really a lot of input. Another benefit of this user memory module is that we create a personalized assistant for each participant, for each user. This way, the voice assistant can suggest personalized topics based on the interest and preferences of the user. And the second extension is the challenge engine, where we proactively inject a set of predefined topics. This is intended to start conversation and keep the conversation flowing. But also, we designed the challenges and the topics in a way that we extract key biographical facts that are useful in a sustained biographical dialogue. For example, life events, special interests, hobbies, and so on. And this technical architecture, as I said, is completely self-hosted. This is important for data protection and privacy. And this system can even run without any internet connection. We use off-the-shelf open source frameworks for that, as you can see here. This plugin-based system allows for modifications, and each block of this diagram was modified by us to support the use of the needs of the elderly and the German language in particular. So, for example, here we can see some of the example questions which are contained in the challenge engine. The challenge engine is not limited to just chatting. In theory, you can also deliver educational lessons, or you conduct interview-style questions. And we also did some extra work for the text-to-speech model, where we did a small-scale study with a preference ranking for the elderly. And we discovered that the elderly prefer slow-speaking female voices. And this open source models allow us to create a voice clone model, and thereby we can create a custom voice that is modified for our needs, mainly for slow speaking, tone of voice, articulation, and so on. Here on the left-hand side, we can see a state diagram that I will skip out of time constraints. This should visualize that we suggest topics, but the user can also reject them and talk about their own interests. So now let me quickly describe the study design. So the study will run over 4 weeks with 10 participants, and we have an intervention group and a control group. At the beginning of the study, we conduct surveys and also questionnaires that are standardized to get quantitative data. During the study, we will observe chat logs to extract usage patterns, topics of discussion, and engagement levels. And finally, we will repeat the data gathering and the interviews so that we can analyze the change in the perceived loneliness of the users. As for our data collection methods, we rely on standardized scales. For example, the UCLA loneliness scale is an established metric to quantify loneliness. The World Health Organization quality of life is a questionnaire to quantify quality of life that is designed to be valid worldwide. And finally, we also include technical affinity to understand if technical affinity affects the effectiveness of our method. We also do qualitative data set recollection. We use interviews to analyze the computer and the human-computer interaction and the user's satisfaction and also usage problems with the system. And as I said, we will analyze the frequency of the interactions by analyzing the chat logs. We designed SOVIA to be not as a medicine product. It should not replace therapy or it's mainly intended for entertainment. We designed SOVIA with data protection in mind. So this means that we don't need to store a lot of data. We only need to store the summary and the personality and the user interest. So we can reduce the amount of data stored, which is also useful for legal terms. And also we want to study the problem of overly anthropomorphization of the users, because as I said, the elderly, or a subset of elderly, they do form friendships with the voice assistant and they treat them as a real person, and sometimes that's can be worrisome. So, as a final takeaway, we created a research design for SOVIA, which is a social voice assistant. This work is publicly available in upcoming publication, and we are able to share the whole setup for replication. We add a challenge engine and a memory module to existing voice assistant loop to create a social voice assistant. And our architecture is provider agnostic. This means we are not reliant on a single hoster or a model. We can switch in and out plugins as we want. And this research project isn't only focused on the technical side, it also has a social aspect. That's why we designed those field trials and evaluations in this way to gather a much quantitative but also qualitative data that we can combine into a single coherent analysis. So now I'm at the end of my presentation, and I thank you for your attention. If you have any questions, you can either ask me or you can contact the head of my research lab, Dr. Florian Wahl. Thank you.
Thank you so much. And with that, again, the question to the room. Are there questions? Yes. The first question is coming right up.
Yeah, thank you. Yes, could you explain a little bit on the physical form of the interface? Is it like a phone or a tablet?
It's a tablet computer, yeah.
Oh, okay.
This has the benefit that it's mobile. It also has a display as a second channel to visualize the text in case of hearing problems and so on. And it's also handy and mobile. That's why we choose it.
Okay. And is it always on, or is the user decides when the system talks?
It's not always listening. It's based on the user has to engage the interaction. Okay. But this is a design decision. We can change it.
Yeah. Thank you.
Thank you very much. And I saw there was a second question.
I had the same question.
Oh, you had the same question. We do have one more.
Hi, I'm curious about, I understood from your talk that you are also thinking about it, but can you elaborate a little bit on the issue of potential or real over-reliance, where people are kind of sinking into relying on this tool instead of maybe making, I don't know, luckily I'm not in those shoes yet, but making an extra effort to reach out to actual people around them.
Well, this is a kind of double-edged sword, because we want the system to be rather restrict. So for example, we forbid any illegal activities or advice for self-harm, but we also limit any kind of medical diagnosis. But the more you restrict the model, the less useful it gets. So, for example, if you want to have a true social companion, the companion should also reveal to you when you have like a bad idea or want to do something idiotic. And those LLMs usually they only want to support you, but they will never give you a true meaningful answer if in the case of a stupid idea.
Sorry, if I may, I was more referring to the fact that you basically replace contact with other humans through using a tool like this. So that's kind of what I'm trying.
Yeah, that's a valid concern, but we never designed it to be the sole contact point. It is an extension to everyday medical care, but it also has use cases for people who are with reduced mobility who could benefit from these systems more than the general population.
I think we have 2 more questions.
Hello, hello, hello. Thank you very much. I had a question. I have a couple questions actually. One is where is this project? Is it already being tested? Is it currently with these 10 individuals?
Currently, it's still in development. The trial run will start in July and in August. We do some internal pre-tests, but it's in the development stage, yeah.
Okay, and my second question was regarding further use cases of this. Could this be used for perhaps helping people with early dementia and other things in order to...
Yeah, that's a good idea. First, it's a well-known fact that social isolation and loneliness can affect cognitive decline. So this is like one possible treatment. Dementia, yeah, we didn't thought of that specifically, but I think that the personalized user memory can help with that.
Okay, and then final question in the second row. Thank you, Julian, for bringing the microphone.
Thank you for the talk. I think I also have 2 questions. My first question is, maybe I'm a bit slow, but I don't think I entirely understood what the point is. Like, what is the question you want to answer or the problem you want to... do you want to prove that the setup works, or do you want to prove that AI helps old people feel less lonely? I didn't quite get what the goal is of the study.
So we rely on established questionnaires, so we don't need to invent our own metrics for loneliness. That's why you use the UCLA loneliness score. And we designed our study so that we collect data at the start and at the end, and then we can compare the change over time. But we can also compare it between the groups of the treatment group and the control group. Sadly, there is no possible real placebo group because obviously you know when you're talking to someone. But we decided to measure the change after the trial.
So it is about the perceived loneliness of the person.
Yes.
So okay. And my second question would be how that decision was made that it should be for elderly people, because I don't know, but I feel like it's also a discussion about how teenagers feel very lonely.
Mm-hmm.
I don't know.
So actually, a lot of young people already use those systems for companionship. For example, ChatGPT. In our case, our research motivation stems from our previous experience where we deployed those commercial voice assistants into the home of the elderly. And also the elderly use those systems quite differently because, as I said, a young person may very well know that the system is just a genie in a bottle, But for an elderly who is like completely stunned by this technology, this has like real risk of anthropomorphization and forming real friendships. But yeah, of course, the system can also be deployed in the general population. So it's not limited to the old elderly.
Perfect. Thank you so much for all the questions. Thank you for your answers, and thanks for being here. A big round of applause again.